Hi, myself Polished and you are welcome to my channel Smart Polished. It is the fifth video of time series analysis using statistics and programming language of R. In this video I will discuss about so many things. The first one is running diagnosis on ARIMA model. So suppose there is an ARIMA model I already created and I talked about it before. So how can you diagnose on that and fix it that your ARIMA model is good? To do those things, you should have to validate your model, right? To validate your model, first we'll create a model with my data set of this one and order p, q, and r values is like this one. I told already these values should be limited in 0 to 5 and fixed is this one. And you should have to make one more thing, transform pairs is false. So what is the transform pairs will be there? It will should be false. I mean corresponding values should be in will be taken an action. Okay, so it is storing with the variable is m. After that I'm doing the diagnosis on that, my ARIMA model. I'm doing the graph diagnosis on that and it will show you the graph of like this. So its graph field is very significant for statistician, so you can understand from the graph that how the data is correlated to each other and with the standard residual and autocorrelation function residual. It's how it is look like that. That first one is very high, after that it is in flat format. So all these values you should have to consider from there to diagnose your model, autocorrelation model. After that, suppose you want to make a forecast. Okay, suppose you want to make forecast means predictions from the ARIMA model to how to do this thing. So suppose predict.m will give the predictions, like the predictions values is like this one, that it will come the predictions of the time series start with like this one, end with this one, and frequency is one. Okay, and standard estimation, AC means for standard estimations, that time series start and end is like this and frequency is like this one. So now predict with the forward 10 values, what will be the values? Okay, so we can do this thing. So it is given forward 10 values will be like this, started from 0.72 dot dot 2 like this way up to here. It will give the forward predictions values of like this. So actually what is the actual value? We are predicting m up to n, n is equal to 10, up to 10 predictions values we are training, but what is the actual value? So actual values is like this one, where first value is minus negative to 0.44 to 15 to 1.5 like this way. So on that basis it's predicted that the next predictions of the forward 10 values will be like this. So it is the predictions from there, and this one is the very important one. We will deal with the share market data to predict the future market predictions, or to forecast about the particular price, what it will be in the next week or what it will be in the next day. We'll get some insightful ideas from here. Now in the second and the forward steps, we'll go forward to testing for mean reversion. So mean reversion is nothing. Suppose you want to know your time series is mean reverting or not. So it is giving the mean which is good or not. So for that thing you will get understanding. If your p values is very large, then you can say it is not reverting. So always we'll expect that our p value should be is less than 0.05. So we can say it is in mean reverting. So for that reasons you should have to import the library t series. Here I'm importing the libraries, and adf.test code data is here. Okay, code data I'm giving, and it is specially using the algorithm dkey footer. Few these algorithms they are using, so you should have to remember this one, where I got the p value 0.23. 0.23 is not so good. So let's start with another one. So here it is also quite not good. Now plot the first one, open ones. Now see your data values is giving like this. Okay, so So this one is quite trending, you can say, but you cannot give insightful ideas from here as the given data point of pg.opened. So let's go with the close one. Here if one will go the close one, it is gives a data trending values, or when it is closing as the day point with respect to its values, it is like this. Okay, fine. So you will get the idea from here. And most important things I already told, when you will run these things, if you got the p values is very large, so you can say it is not so reverting. So we will always expect low p values. Low p values is the high accuracy, you can say your estimated estimation is good. Now in forward, we'll move forward to the if you need root library. What is the use of this? Actually, if you need libraries is useful to ADF, auto correlation functions, if you want to test on that. So it is very useful. So let's run on the thing and you'll get the idea. So you'll get the idea of like this. So this is all about this one. Now I'm moving forward to smoothing a time series. Suppose you have a time series, okay? So this one is quite complex, but you should have to make attention here, pay attention here to understand this good way. So to deal with the smoothing curve, you should have to input first current smooth library. Fine. I'm making a series sequence and giving the name as T. Then after that I'm making noise unknown. It's normally distributed of 201. So unknown I'm distributed. After that I'm making a function which is sine of T plus noise. Okay. So I'm making a function of this. Now my T is ready. Followed by I want to calculate the length of y. Yeah, length is calculated. Now I'm calculating one more thing. Vw is dp. Dp is nothing. Dp will calculate about the linearity of your data. So to more about, you can search it here, dpil. So it is such the bandwidth of local linear regressions. Okay, and selected local bandwidth relation is doing the tasks, and it will take the three argument. T is your sequence and y is the function, and grid size is your grid size. Okay, I mean length of the y, you can give it here as well. When you will make now low copy localizations copy, I'm creating with that. Here x will take the t value and y will take the y values, and bandwidth is the bw, which one I already created right here, and followed by grid size. Grid size is nothing, the length of y. So we will created this one. Fine. Now smooth dot lpy. uh, so it is the smooth functions. Now see our what is actual y is look like. Our actual y is look like this. Okay, y is nothing, y is this one only. But when we apply the smooth functions, which one we already created at here, okay, with the lp, so it will be look like this. Let's see, look at magic. See, my previous data is look like scattered. Now when I make it smooth, so the smooth function is like it is a cosine curve, like look like similar to cosine curve. Okay, so if you understand, and with that one, it is the last of finishing video. So hope guys, please give you 1 minute that my all the motivation inspiration and from you for your single click of subscription or single click of press the notification bell, subscribe my channel, like my videos is inspire me. And I'm really believing myself that I'm really good when I able to help you when you are facing the problem. And so many guys come across to my mail id and ask me so many questions and ask regarding help and something else. I'm really thankful to them who are reaching to me. And I all about that my all the revenues and inspire from YouTube only. So for your single click of subscribe or watching video, it's inspiration for me. So it is kind request from you, please subscribe my channel, like this video, share the video with your friend and those that relevant to this domain, and press the bell icon for more notification and stay touch with me. Have a nice day.